All right. Hi, everyone. Hey, thanks for joining. Make sure we're all set up and going here. Oh my God, we have so much to talk about. Yeah, I'm trying to play it super cool, but I'm really excited. So let me just finish getting everything set up. I wanted to get all of the screen caps that I want to talk about for this because legit, I have so much I want to talk about. Hey, yeah, people are here. Thanks for coming by. Had a few subscribers since we last talked, some followers, so thanks to everyone for subscribing and following. And yeah, we're gonna get straight into this. So I don't need to. Mohammed and Jedi AK are on. Hooray! We're going to talk legit science is basically what it's coming down to. There's been a few episodes where we've kind of talked, abstract thoughts, mostly because I'm not a biologist and it required a lot of biology. So thanks for sticking with me. But now we've got some science, astrophysics to talk about. So the first thing that we need to discuss is the whole driver for this entire kind of premise, which is, let me make sure. Yeah, cloaking devices. How do cloaking devices work? This is a thing, and I actually brought this up a couple of episodes ago. So if you remember, any loyal followers, this is a thing. And when they showed this screenshot, I lost my brain. It was amazing, mostly because you all know how I feel about my trampoline of space-time, and this was a freaking trampoline of space-time. You can see the mass that's being bent, and we've got gravitational bending going on. So I'm super excited about this. And the whole driving force is, how do we break through Klingon cloaks? So what kind of strategy can we do in order to do this? Well, as I've talked about before, and now they kind of clarified it, it's not clear what kind of technology they use to cloak ships. We have in the Star Trek world, throw it around as in it's Romulan technology. The Klingons have it, and how do they do it? But we've never really delved into it that much. And in this one, they kind of did. They basically said that they have a way to bend the electromagnetic waves, i.e. light, stuff we can see and mostly detect, in order to disguise themselves from the outside, which is awesome and perfect because lately in this world and in current astrophysics research, that is how we study the universe, is through electromagnetic radiation. We use radio telescopes, microwave telescopes, X-ray telescopes, visual telescopes like Hubble, but we don't really have any other way of doing it. And so if you did have a species or a culture that is able to bend electromagnetic radiation so you don't detect it, then they can legitimately disguise themselves. But I'm super excited about this. Gravity's a thing. And for those of you who've followed me for a while, you know that my background is in space-time and detecting space-time and detecting gravity as a different way of detecting the universe. And so the fact that this whole thing was well, we can't see them with electromagnetic radiation, but we could detect their gravitational signature. Yeah, lost my brain. Super excited about that. So that was amazing. But let's learn some actual science. All right, for those of you who, because I know I have quite a few people who watch this and don't watch the show, I'm not going to spoil too much for you, or don't watch the show yet. I don't want to spoil too much for you. We're going to do some legitimate science here. So if you've seen the episode, great. It'll be even better. But if you haven't, there's still going to be some science that we can talk about. So the first thing is cloaking technology. So like I said, they throw out the idea that the way that the Klingons are able to cloak their ships is through bending electromagnetic radiation around them, that they can disguise themselves so they're not able to be detected. How do we do that? Well, there is a group in Rochester that is trying to come up with a way that you can do this. So the diagram I have up here is one of their sort of press release photos about how to bend light around an object. So the fact that they actually say that they're bending light, this is this method. Now, have we developed cloaking technology? No, unfortunately. But we have a start to it. So if we want to go to a certain amount, we're able to do that. And I'll show you a picture that they released as well. This is actually the Rochester cloak, which if any of you are Jane Eyre fans, is the Rochester cloak. But it has nothing to do with that. It has to do with Rochester as a place and an institute. And what they do is they have their lab bench. So if you've not worked in optics or anything like this before, this is kind of a thing. Now it looks kind of green and cool and sci-fi, but optical lab benches are a way to do a lot of optics and physics research. And what you do is you line up lenses and you're able to have exact distances, and you can see on there sort of that point where the light converges and then diverges again. Those are all very physics-based things, and you're able to use a light to bend around an object in the middle. So what they did is they basically played with all these sort of lenses and different light passing through to say, how can we deflect light in such a way that you can see what's behind the thing, but not see the thing itself. In this case, it's a hand, and then you can still see the wall behind the hand. Awesome, right? Like, this is legit cloaking technology right here. But the difference is that this is only effectively in one dimension. This is, you have to be looking directly down that lens, directly at that wall, directly at that big, cross in the back, in order to miss the object that is in between there. So, yeah, but it's a start. We don't have cloaking technology. We don't have warp drive technology. We'll get there. I gotta join Starfleet. We gotta get warp technology and cloaking technology. So we're getting there. But yeah, so this is legitimately a way that scientists have been trying to develop cloaking technology, is to bend electromagnetic radiation in such a way that you don't see what's actually in the middle. So they are using this example from, this Rochester cloak that they have. Sorry, this example. And that's how it functions. Now we just need to make that 3D, and then you can hide a ship in the middle of it. Piece of cake, right? So how we bend light. Now this is a tricky thing. If you have a mass, so we're going so that's kind of cloaking technology. Now we're going to take another step, and we're going to talk about bending light around objects. So you can bend light with different lenses, and let's imagine that they have some sort of lens gizmo thingy set up that allows them to bend the light around them, so you see in all directions, so you see what's behind, but you don't see them. But they're still there. They're still there. And one of the effects from that is that you're going to be bending space-time. You're going to be putting a bowling ball in a trampoline, which is my favorite thing. And that's awesome. It's perfect. So you can see here, this is an example of what we call a gravitational lens. So if you imagine you're sort of the green dot on this side, and then you have an object in between, and you're looking at the stars back here, the light from the stars are going to get bent around this object and look at you. And I can't, because I'm not in front of it. But what happens is you can see up on the top, I'm too tired to do this, forget it, the apparent position up there. You can see the two apparent positions, and that's because you can see the light is getting bent around, and then it gets projected back, so the viewer thinks that they're seeing two objects of the same thing. And this is how we do a lot of astrophysics, is detecting the light being bent around just in a purely gravitational standpoint. So if we go on here, so you can see here again, that bubble is sort of where they are saying, okay, we think a Klingon ship is here. and again, this is, remember, you can kind of see in the writing there that it's like the simulation. We think the Klingon ship is in this bubble, and it's bending space-time this much. It's warping space-time around it. There's even some cool visual effects about being warped around it. How would we actually map that out? How would we actually detect it? And there is a way, and it has to do with this gravitational lensing on a very micro level, and it's beyond the technology we have, but it's not beyond the physics that we have, which is awesome. It's totally possible to do. We just don't have that level of technology in order to do it. But the physics is totally sound. So let me see, going on. So we have, if you have an object, it's going to bend space-time, and light is going to bend around it, just like they kind of show here. Now, you can see this here on a much bigger scale. And so this is where it's connecting to how we actually study astrophysics, in the sense that we see huge objects such as galaxy clusters. So if you've seen my videos on your cosmological address, where we talk about, you have your solar system, and then you have your star clusters, and then you have your galaxy, and then you have clusters of galaxies, then you have the universe. This is kind of countries within a continent in the broad scheme of things. So this is kind of big scale astronomy that we're looking at. So if we're looking at galaxy clusters, you can see in this diagram, you have Earth and a galaxy over here, but you have a huge galaxy cluster in the middle of it. I'm getting better at this, I promise. I've only been doing this for 2 months. You have big galaxy cluster here, and that galaxy cluster is so massive, it's bending space-time so much that if you're trying to observe that galaxy in the back, its light is getting bent in all directions around it between Earth and that galaxy in our line of sight, that's getting warped around because of the bending of space-time. We legit see this. So here's an actual image of one. And I picked this because it's a smiley face. Space is adorable. But this is us looking out in space at trying to observe, we're observing space. This is an image from Hubble. And you can see the little curves there, the big swirls bit. That's not what the object is. What that is just a flat spiral galaxy. But what's between us and it is a huge cluster of galaxies, which are warping space-time so much. They're bending space-time that this galaxy actually appears to be totally warped around. Now, if it was a perfect line of sight, it would be a perfect circle. And we do see these. We are close enough. But you can get close to that because it'll just be slightly off angle. It's not going to be totally perfect. And so you get this big curve. And so you can imagine, if you're thinking of this galaxy cluster as a Klingon ship, basically what's happening is that you have, in this circumstance, you have a galaxy cluster and then galaxies behind it that warp around it. In the Star Trek circumstance for this episode, you're talking about a cloaked Klingon vessel, and then the stars and light behind it that would get warped around, that you want to try to fix that. Try to detect that, because there's going to be some gravitational presence there. So awesome. On board. We're good. We're feeling happy. We're feeling really good about this. So let me see. So this is an actual gravitational lens. And then now this is us trying to observe space, right? This is us as humans on Earth, not in Starfleet, unfortunately, trying to just map out our universe and try to figure out what's out there. And we use the warping of light around gravitational masses in order to do that, just like they try to see the warping of light around a Klingon ship. Okay, so we'll go with that. And then they start talking about, well, we've got to move. We have to get different angles. We have to go from one point to another to try to map all of it. Even better, because when you think about the last image I showed where we've got a galaxy cluster and galaxies behind it, the best we've got is just, there's a bunch of mass there. And then behind it's a galaxy that's getting warped around. We can kind of tell how much mass is there, but it's a bit floofy. Just because we have one line of sight. We can say, all right, here to there, that's what I see. If we were able to move around it, and space is very big, we're not able to. We're not able to. Not able to. But if we could, then we would be able to really map out in detail the distribution of these various masses and galaxy clusters, even if we weren't able to see them. Which brings me to a good comparison between a cloaked Klingon vessel, because we do, a cloaked Klingon vessel, and something astronomers are actually trying to study, that being dark matter. So, imagine dark matter is your Klingon vessel. Can you tell I'm really excited to talk about this? Imagine dark matter is your cloaked Klingon vessel. The issue with dark matter, and again, I'm going to do a whole VOD, a video on demand, a whole episode for my show next month on dark matter itself. But the quick background is that astronomers 100 years ago, trying to map out galaxy motion, all this stuff, they're figuring out that the further you are away from the center, the slower you rotate around something. They start mapping out our Milky Way galaxy, realize that the stars further away from the center of the Milky Way galaxy are moving a lot faster than they should be, which implies that there's a lot more matter there than we can actually detect. And this is where dark matter came from. This idea that there is some matter out there, something that bends space-time. It creates some gravity effect, but we don't know what it is, and we can't detect it, and we can't see it. So you really can legitimately say, like, dark matter is the equivalent of a cloaked Klingon vessel that astronomers are trying to figure out. And but one of the ways that we can do it is something like this. So this image that I'm showing is something called the bullet cluster. And this is a pretty famous image. Some of you may have seen this when, you know, pretty astronomy pictures. But there's some pretty cool science behind it. And basically what it is, you don't see this big gravitational lensing effect that you get to see with the last picture that I showed, where you get a big smiley face. But what you're looking at is two galaxy clusters which have collided and then sort of passed through. So they're right at this stage where they've collided and then gone about there. And working in astronomy, you need to piece together pieces of a puzzle, because the timeline for studying astronomy is far beyond our lifetimes. It's far beyond our even ability to observe space from a scientific perspective. And so you can look at this and say, oh, that's a galaxy cluster collision, but you're never going to see the galaxies collide and then move past. So you piece it together like a puzzle. Now, what we have here is, you see there's a bunch of stars, galaxies in the background. But what you see in the foreground is purple and pink. What is it? Well, the pink part is the bit that we would normally see and that we would think of if you have galaxies collide and you have a bunch of dust and gas and some stars. And, you know, stars aren't really going to collide. They're going to move past. But you're going to get dust and gas that's kind of going to run into each other and kind of slow down a little bit. Again, space is big, but it'll slow it down. It'll collide. And so as you get past this point, you can kind of measure that. We can see the heat from this dust and gas. We can see it get darker. We have X-ray radio. We have all these different ways to measure dust and gas. So we see it, so we can map it. So we say, okay, here's all the dust and gas. Color it pink. We're good. Now we keep observing it, and we see that light is being bent around, and we see these gravitational effects far beyond the pink part. We see this bit that we're coloring purple that is bending space-time, but it never slowed down. It just went wonk. We're good. That's effectively what we're looking at. And the only reason we know that's there is because of this sort of background mapping that we're able to do from the light getting bent around. So these galaxies collide. We have something is just going, and it's not interacting. And that's why we can't see dark matter. It is the cloaked Klingon ship of astronomy, which I'm using for now and eternity. That's my analogy for dark matter. It's a cloaked Klingon ship. So I hope that explains a little bit of what dark matter is and kind of that there is a legitimate tie from the science of what they're doing in this last episode of Discovery to astronomy that's going on right now, is trying to map out objects that are there that we just can't see. They don't emanate in a way that we totally understand, that we're still trying to study in a very novice sort of way, a very pre-warp, pre-Starfleet culture sort of way. So, all right, so we've got this. We're all on board, feeling good. This is awesome. Now what? Now we've got to map out this Klingon ship. Okay, so then they start talking about putting 2 sensors on the Klingon ship so we can triangulate it. All right, awesome. On board. Again, you can think, and it's not totally clear, and I need to watch it again to figure out how much of this is like figuring out just the warping of gravity or how much they're doing background stuff, but I get a sense that it's just kind of the warping of gravity to map it all out. Using triangulation, as nicely demonstrated in this screenshot, that we are using triangulation with sensors. Fan-freaking-tastic. This is amazing. Again, if you want to really map it out, you've got to get different perspectives. You can't just look in one direction, and you can't just map it all out from there. So how does a triangulation work? Now, a lot of you, oh my God. Mohammed, we are definitely getting to the glowy sensors. That's on my additional notes. So you put these super obvious sensors, I'd at least cover it with a blanket, onto the Klingon ship. Awesome. We're good with that. Triangulation. How does triangulation work? So actually, because we use triangulation all the time in astronomy, in geophysics, geolocation, triangulation with satellites and location, all that stuff. Like this is a known thing. This is a known quantity. This is a thing we do. So this is kind of a cool map that I found, because we do it in very 3D way. But if we're talking about triangulating a Klingon ship in space, I'm going to bring us down to the 2D level. And that is trying to map out coastlines. Again, bowling ball and trampoline. Let's bring it down a dimension, just one dimension. It'll make us a little easier, a little more comprehensible. So mapping out the coastline of Long Island using triangulation. So you use multiple sensors, you use this sense of triangles, and you say, all right, so it's this distance to this point, it's this distance to this point, this must mean that we've got here, but you need both of those points. Triangles are useful things, and they're used all the time. We talk about if you're going to geolocate something on the surface of the Earth, you need a 3-point triangulation in order to do that. And for this, you can see how many triangulations you need in order to get understanding, in order to map something out. Hence the 133 micro jumps that are required to map out a Klingon ship. Now, someone asked me on Twitter today, is 133 correct? I don't know. I haven't spent enough time, but don't get me wrong. I will answer this question at some point, but I need to sit down and think about the dimensions of a Klingon ship and to what fidelity you actually want to map it out and how much of a distance you would need in order to do it. Oh, this is happening, but I haven't had time to do it. But I could, and I will. And the whole premise is just thinking about triangulation and mapping and how you use different points and different angles to get a full picture of a ship, i.e., warping around, jumping around a Klingon ship to get all the different perspectives. Even though you have 2 sensors in the same place, every time the third point of that triangle moves, you're getting a new measurement. So you're able to map it out. So we're good with that. Yeah. The 133 jumps, triangulation, every time you jump around, that's a different length, and it's a different map, and you're able to map it out. So we're good with that. Carrying on. I love this episode. Carrying on. At one point, and this is going to get a little more spoilery for those of you who were here for the science and less for the spoilers. They talk about Stamets. He's having a hard time, and obvious reasons. kind of wants to stop doing it. And he gets a pep talk from our captain saying, look at how much we've learned. Look at how much. Science! Again, this is why Voyager is one of my favorite series, is because Janeway always reminds us that we're explorers and scientists. Keep that in mind. And this does a great job of that. This is exactly that case. So they have obviously been jumping all around. Now, you've heard my discussion about conflating galaxies and universe and star systems, that those are not the same thing. And there's definitely an implication that they are exploring the universe when Star Trek has never stepped foot out of the Milky Way galaxy, but that's okay. They have explored more of, we're going to say the galaxy, more likely that also just the quadrant, than has ever been done before. And they do have a distance limiting factor that they have mentioned. So I'm okay saying that they have explored the majority of the Alpha Quadrant that hasn't been explored before in greater detail, because they've been jumping from point to point as opposed to traveling through a well-determined, well-mapped out path. They show up somewhere and they can map their region around them. And what he says is, I wrote this down, we're finding pockets of negative mass which could point to parallel, I think he said parallel universes, of the mycelium network. Yeah. Little geek out about that. So pockets of negative mass. I don't need to go into all of that. I've talked about tachyons. Tachyons are negative mass. Tachyons are an actual physical, theoretical, but in the physics world, they are a thing that exists. It's not sci-fi technobabble. Tachyons are a thing, and they are negative mass. It's saying that, again, any mass is going to bend our loving trampoline. Tachyons would invert it. They would create a bump, negative mass. So what they're finding is these bumps of negative mass. Now, this is a thing that people are trying to study when they study cosmology. How is our universe shaped? Are there weird kind of inverse points of negative mass? And especially when it comes to multiverse theory, are there any points where there could be, we have our sheet, our trampoline, and remember, you can be like my Astronomy 101 student. What's under the sheet? What's in the box? What's under the sheet? Well, what's under the sheet might be a parallel universe. And if it bumps into ours, then it might pop up our universe. And so we get these weird pockets of negative mass. This is a thing. And it's kind of legitimately talked about. So this whole concept that they might be finding these ridges that may be caused by parallel universes bumping into one another, because you have our sheet, you have our sheet. This is called the brain multiverse theory, by the way, because membranes that will bump into one another. And this negative universe space, hyperspace is sometimes referred to, could be another explanation of that. So we're all good with that. And then spoiler warning, spoiler alert. 3, 2, 1. End of the episode. When they jumped somewhere they don't know, and the implication is that they're in this like negative mass hyperspace area. My Trekkie brain is freaking out. And because they're kind of getting it, like even, okay, biology, spore network, spores in space, we have beat that to death. Now let's imagine that it helps us map out our universe and our happy place and our trampoline of happiness, and that it's one universe here and then another universe, and we have brain multiverses or parallel universes, and we're finding pockets of negative mass. What could that be? Now, I've given talks in the past about multiverse theory and multiverse theory in Star Trek. Star Trek is one of the few sci-fi that actually doesn't do multiverse. They do parallel universe. And parallel universe is a very specific thing, and it still works in this construct that's being discussed in this episode, in that you have your universe, your space-time, you're on top of it, you're all happy, this is your trampoline. Anytime there's mass, your trampoline bends down, and it's sort of weirdly shaped. But a parallel universe is just the upside down. The upside down. Different thing. But the upside down. And imagine if we're up here, there's an upside down parallel universe, they have mass in the parallel universe that's going to bend up, and it's going to look like negative mass on that side. And some of you may have heard of it referred to before as the mirror universe. I really hope they're in the mirror universe. I have no authority on this matter at all. But we're here to have fun and speculate and talk about the science. And if they're going to talk about pockets of negative mass and parallel universes in Star Trek, we're going to talk about the mirror universe. Because frankly, if they have pockets of negative mass and the mirror universe is the upside down parallel universe that we have, then that would be negative mass. With me? With me. All right, we're good. Hearing no objections, we move on. So we're good with the mirror universe thing. So the big things from this episode that made me happy dance were so remember the cloaking concept, saying and putting in detail this idea that there was light being bent around a cloaked Klingon vessel. That's how they cloak, is that they bend light and electromagnetic radiation in such a way that they become invisible. And this is like the technology that is, or the science that's being developed at Rochester, with the Rochester cloak in the same sense, but we've only got it to one dimension. That if you're looking down one path, light will bend around so you can see what's behind, but you don't see what's in the middle. Awesome. Now, imagining you have that technology, how do you utilize that technology, and how do you actually detect something that's there? Well, even though you can't detect it with electromagnetic radiation, you can detect its gravitational presence there. And so you can detect the warping of space-time using either gravitational lensing or triangulation, or combination of those. So what you're doing is you have sensors set up, you have two sensors, and then you have your detector. And what you're doing is you're seeing this extension, this lensing, this warping of space-time due to a presence of gravity. We do this a lot. There are actually satellites and sensors in space that are doing research on microgravity changes for Earth. Very cool. This is a thing. We are capable of it. But again, on a small scale. This is extending it to a bigger scale, which I'm okay with. I'm good with this. And yeah, so if we're able to detect these little slight gravitational changes, then that's awesome. On board, no problem. And using triangulation, which is a thing. So got all that. We're good. All of the decloaking the Klingons. Happy science, good science, excellent science. Science that's like legit points to science that we're doing right now, which only makes me excited because it means that like I'm this much closer to getting into Starfleet and meeting the Vulcans. Because the more I can draw the parallel from where we are now to where we're going to where Star Trek is, the closer I get to Starfleet and First Contact. So we're good. Now, just a few additional... Oh, and then cloaked vessels. I got distracted with the idea of going to Starfleet Academy. But addition to the cloaked vessels, we talk about this multiverse that they threw out. This idea that like they're finding pockets of negative mass, which does imply that there could be parallel universes in the sense that we bend space-time this way. A parallel universe in the upside down would bend space the other way, which would look like negative mass. So there may be a parallel universe. Then weird stuff happens and they end up somewhere creepy. And mirror universe. I may be totally wrong, but you know what? Multiverse theory, it's a thing, and that's what we talk about. So additional thoughts on this episode as we wind down for tonight and our final episode until, well, our final Science of Star Trek Discovery episode until next year. The science behind the goatees. I think we've established officially that mirror evil universes require goatees. I feel like this has been legitimately established. So, I mean, good question. I will work on what the science of that will be, but I feel like I should just call in a biologist to say, explain that. But we all know this is a rule. You're in an evil parallel universe. You get the goatee. So final observations. Throughout some stuff that we know Star Trek lore the whole time. Klingon ships decloak when they go into battle before they throw their shields up. I'm good with that. This has been used tons of times. This is a thing. we're good. Yeah, if they're using cloaking technology, it makes sense. Because whatever, and I'm going out on a limb and saying this. This is just my scientific brain trying to rationalize Star Trek. It's literally the whole point of me doing this is that you have sensors on the Klingon ship that are somehow warping electromagnetic radiation in such a way that you become invisible. I'm going to assume that requires a bit of power. And would make your own, because if you're sort of using all these lenses to warp light, I wouldn't want to be in that warped light thing and say, oh, that ship I want to hit is right there. I don't trust that. Because you saw the light being bent at the beginning of the episode. That means that the light might not be where you think it is. So if you look at a ship and you go, I think it's there, I want to drop my cloak before that happens and say, oh, yeah, no, it's over there. Fire. So, yeah, legitimately, I'm good with that. And you also don't want to really beam on board. So we're actually talking more just like actual physics than any technobabble that, you know, there's issues with bending light to that extreme that you would want to get around, both for being beamed aboard and for firing torpedoes. The other thing, I'm so pleased I don't have to talk about this because I'm not a biologist, how to mask life signs to appear Klingon. That was a thing that they did. We'll leave it at that. So say their human signatures can appear Klingon signatures. These are all of my afterthoughts of here's some cool science that someone else more confident than me in how to mask human life signs could explore. Excellent. Moving on. Mohammed, this one's for you. I legitimately got stressed out watching this. Yeah, thanks, because you're the one I'm going to call when we talk about detecting life signs. Yeah, I have no idea how they do that. And I don't think, correct me if I'm wrong, I don't think they've done this in any other Star Trek series where they've masked their life signs to appear as another species. But I'm going to kick once I said that out loud, I was like, I know, I feel like there's something, but I'm not thinking of it. If I think of it, I'll put it on Twitter. Yeah, no, it doesn't count if it's in Orville. But nice try. But this sensor stressed me out. When she put that down and it had Starfleet on top of it, and it's glowing blue, I was like, oh my god, throw a blanket on that thing. Like, surely that still is okay if you covered that up because you're in stealth mode. And if you can come up with Starfleet tactical vests, I feel like you'd be able to come up with sort of a way to disguise your giant blue Starfleet sensor. Just saying. It's more, I don't care that much, but it's more that it just viscerally stressed me out with them being in tactical creepy mode and then walk. Bye. That's getting shot down super fast. Just saying. So yeah, aside from that rant and all those fun things that I don't know how to talk about, such as masking life signs, is really the main thing. The cloaking technology, the triangulation to break through and detect the Klingons, and the negative mass parallel universe. Awesome. Amazing episode. Loved it. Loved the shots. That shot. That was legitimately exciting as a space-time scientist watching this and thinking about how you would detect a cloaked ship that is deflecting electromagnetic radiation. I'm good with this. I thought that was so solid and I was super happy with it. So, that's it for me tonight, guys. Thanks for hanging out with me. I hope you felt 50% of the enthusiasm I did for this. Because I was so happy and so excited. And I'm like literally writing a lecture course within 24 hours of watching this episode, but I hope it was educational. You spent 40 minutes learning about space-time and triangulation, but I'm glad you guys stuck around. It was really fun talking to you, and I'm trying to decide so my VODs are coming back. November 30th, they'll be back. I'll have a big string of them until I burn out and need some time to myself. But I will keep you informed. And if you have any ideas for episodes, please send them my way. Right now I've got dark matter, dark energy, Hubble, the expansion of the universe, planets in video games. I need a lot of suggestions for, because I think I was going to do one episode on it, and then I decided I'm going to break it up into planets in Mass Effect and planets in video games. We're definitely going to talk Halo, we're going to talk Destiny, we're going to talk all that stuff. So if you have any other sci-fi video games that you want to talk about the planets and exploring the planets, send them my way. You can find me on Twitter at Dr. Erin Mack, Dr. Erin Mack. And so VODs are coming back at the end of November. They'll be weekly on Thursdays. And I'm glad you appreciated the Stranger Things reference without me ruining anything. And then I'm going to keep doing my live streams. I'm not going to have anything scheduled next week. I'm traveling, and it's the mid-season finale. But if you guys have any ideas for things, if you just want to do a chat on Tuesday nights and talk about the science of sci-fi or just the science of Star Trek, we could talk about transporter or warp or any of that stuff and just kind of geek out for half an hour, 45 minutes or so. Let me know. For those of you who followed, some new followers, new viewers, thanks for hanging out with me. Again, you can find me at Dr. Erin Mack here on Twitter. And I look forward to hearing from you. So thanks, guys. This was really fun. Enjoy your evening, and live long and prosper. We'll talk Discovery in the new year. See ya.